Hello friends, today we are going to see how to print nodes at distance k from the root in a binary tree. So let's see an example. So this is the binary tree and these are the levels of this binary tree. If we consider the root at the 0th level, then this is the first, second, third and the fourth level of this binary tree. Now if k is equal to 2 means we have to find out the nodes at a distance 2 from the root. So let's see here. So from A, B is at distance 1 and D is at distance 2. So our answer is D. And similarly E is also at distance 2 and F and G are also at distance 2 from the root. So let's write here D, E, F and G are the nodes which are at distance 2 from the root. So similarly if K is equal to 3, then H, I, J, K, L are the nodes which are at distance 3 from the root. And for K is equal to 4, M and N are the nodes which are at distance 4 from the root. So now we will see the program for finding out the nodes at distance k. We will use recursion for writing this program. So let's see the program now. So let's see the program now. This is the code and this is the recursion tree for this code, and this is the original tree for which we are executing the code. So here k is a variable which calculates the distance of each node from the root. So the trick is that in the function which is named as trace, we are going to pass the distance k. For example, the distance is 3, means the k is equal to 3. Now node star p. So this is the parameter which holds the root of the tree at the beginning. So obviously p will point to the root at the beginning of this execution. If p equal to null, then return. So as p is pointing to a node, p is not equal to null, so this condition will not satisfy. Then if k equal to 0, no, because k is equal to 3, so this if doesn't satisfy. So then we go into else. So in else we call the same function, which is why this function is recursive. So trace p points left comma k minus 1. So this means now p will point to the left node of A. So p will point here and k will be subtracted by 1 as we have covered distance equal to 1 unit. So as we have covered one node, we will subtract 1 from k. So initially k was 3, here k will become 2. So here k will become 2. Now let's go ahead. So inside this trace function again we will come, again p is not equal to null, k is not equal to 0. Then again we will go into this trace function, that is trace p points left comma k minus 1. So again p will point to the left of the current node, that is B. So p will point to D and k will become 1 here. Now in the next loop, p is not equal to null, k is not equal to 0. Now trace p points left and k minus 1. Now p will go to the left of D and k will become 0 here. So as the k becomes 0, we have to understand that this is the node at a distance k, because we started from 3 and we are subtracting 1 for each recursion and for each left node in this case. So this 3 first became 2, then 2 became 1 and 1 became 0. As k has become 0, we have found out the node at distance equal to k. So h is one of the nodes at a distance k from the root. Now let's see the execution. So when k becomes 0, we come inside this function. P is pointing to this node, so p is not equal to null, but this condition, that is if k equal to 0, is satisfied, and then we print the data, that is we will print h, and then we will not go into else and we will directly come out of this function. Now in the next iteration or in the next recursion, we will come out of this trace function and we will go to the right of the node. So here you can see p is pointing to h, but when this recursion is over and we come out of this function, we return to the previous node. So we return to the parent of h. This is the parent node and this is the child node. So we return to the parent node and we come at d. So at d, then this trace function is called and we go to the right of this node, that is d. So here trace p points right, comma k minus 1, and we go to the right of this node, and here again k is equal to 1, and when we go to the right we subtract 1 and it becomes 0, and yet another node is found at distance k from the root, as k is equal to 0 here. So I is also our answer. So in this way all the nodes at a distance k are found out. Hey friends, please subscribe to my channel as I post algorithm videos every day, and if you want a video on any particular topic, then please mention in the comment below. Thank you.